Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Okay, in this session, we are going to study the overview of engineering mechanics. Overview of engineering mechanics. In the previous sessions, we covered all the modules and in detail and solved the problems also. Now, here we in this session only brief summary overview, complete course and briefly explaining each module. Okay, let us start with the syllabus which we are having here. There are 5 modules. 5 modules in this course. The module 1, that is M1, is module 1 is related to Introduction to Engineering Mechanics. Introduction to Engineering Mechanics. And module 2 is related to the friction. And module 3 is related to the center of gravity, center of mass, and moment of inertia. Module 4 is related to dynamics equilibrium, that is kinetics of rigid body. Kinetics of rigid bodies. And module 5 is related to impulse, momentum, and vibrations. I am going to give a brief description of these 5 modules and what are the things to be remembered for examination point of view. That is the main objective of this session. Now coming to here, the main objective of this session, again repeating, is that for examination point of view, what are the salient points you have to remember it. We have to focus and we have to emphasize more and more for examination point of view. By attending this lecture, only this lecture, you can attempt a question paper very easily. Let us start with module 1. What are the questions we have to focus? What are the things were covered? And for examination point of view, what are the things we have to focus? Let us begin in module 1. It is Introduction to Engineering Mechanics. First, to focus on system of forces. System of forces, we have to focus. Next one is equilibrium conditions. Equilibrium conditions. And the third topic is Lamy's theorem. These are the 3 main topics one has to focus for examination point of view. Now the system of forces comes under the category of theoretical question, whereas the equilibrium condition, Lamy's theorem are highly useful for solving the problems questions which are coming from module 1. The system of forces, what are the system of forces? Here mainly we focus or we emphasize on coplanar system of forces. There are 2 types of system of forces. One is coplanar, another one is non-coplanar. The coplanar forces are considered as there are again various categories. Number 1, concurrent force system. Concurrent forces system. Another one is parallel forces system. And third one is collinear. Coplanar, collinear forces. One is coplanar concurrent, coplanar parallel, coplanar collinear forces system. What is this coplanar concurrent force system? Again, in pictorial presentation, coplanar collinear means coplanar concurrent. In the coplanar concurrent force system, all the forces acts at one point, concurrent point, but it is on the same plane. Then it is known as a coplanar concurrent force system. Okay. The point is that in the case of coplanar concurrent force system, there are different magnitudes F1, F2, F3 and F4. These are the different forces are acting at one point. If you want to replace all the forces with a single force, that force is known as the resultant force. And calculating that resultant force and both magnitude and direction by using equilibrium of forces or resultant force system. Okay. The next one is parallel force system, coplanar parallel force system. In the coplanar parallel force system, the forces which acts parallel to each other on a beam, these are the forces F1, F2, F3, F4 and F5, okay, which are supported by knife edge supports. These forces are known as the parallel force system. But the point is that these are like parallel, all forces are acting in the same direction. There are some unlike parallel force system. If you consider by removing the supports, consider the reactions, then what will happen here? F1, F2, F3, F4 and F5. F1, F2, F3, F4 and F5. These are the 5 forces acting downwards, but 2 reaction forces, reaction 1 and reaction 2, acting upwards. So, these are, some are downwards and some are upwards. These are unlike parallel force system. Unlike parallel force system. This is like parallel force system. Okay. Unlike and like parallel force system, that is comes under the category of coplanar parallel force system. Now third one, the third category which we have to remember, that is the collinear, coplanar collinear system. Coplanar collinear force system. The collinear means which acts along the line. Okay, collinear. It can be towards or it can go away from that force system. These are coplanar collinear. Again here, the towards acting along the direction. Suppose if we consider a beam in between, yes, it is known as a compressive forces. If you consider the beam in between is going, stresses, a force is acting away from the cross section, then it is comes under tensile forces, tensile force system, tensile force. But these are all under plane, same plane. The coplanar force system is also known as a two-dimensional force system, 2D force system. Whereas non-coplanar force system is known as the 3D force system. For non-coplanar system is 3D force system, X, Y, Z directions. Here it can be either XY or YZ or ZX, GX systems. That's a two-dimensional. For coplanar force system, one has to focus. Coming to the Lami's theorem, the second topic is the Lami's theorem. Lami's theorem is the theorem is used to calculate the unknown forces provided when one force and angle between them are known. Suppose it is the P1, P2, P3 are acting. It is also concurrent force system. We know the angle between theta 1, it is theta 2 and it is theta 3. P1 by sin theta 1 equal to P2 by sin theta 2 equal to P3 by sin theta 3. If we know the P1, any one force, and known the angles, these 3 angles are known, then by equating P1 by sin theta 1 equal to P2 by sin theta 2, P1 by sin theta 1 equal to P3 by sin theta 3, if we equate, then unknowns can be calculated, P2 and P3 can be calculated. This theorem is known as the Lami's theorem. Lami's theorem is applicable only for 3-force system. Okay, and now coming to the topic is that equilibrium conditions. In the case of equilibrium condition system, if the more than 3 forces are acting on your body, if you want to find out the resultant force, the resultant force can be calculated by using equilibrium conditions. That is equilibrium conditions such as sigma fx equal to 0, sigma fy equal to 0, and sigma fz equal to 0. These are the 3 equations, or sigma fz equal to 0, that is for 3-dimensional, or sigma m equal to 0, that is a moment equilibrium. Sigma fx equal to 0, that is algebraic sum of all horizontal forces equal to 0. Sigma fy equal to 0, algebraic sum of all vertical forces equal to 0. And sigma m equal to 0, algebraic sum of all moments equal to 0. If these conditions are satisfied, then the body is under statically equilibrium. If it is not satisfied, sigma mf fx is not equal to 0, sigma fy is not equal to 0, sigma m is not equal to 0. That means the body can move in x direction and y direction and also can rotate. That is the meaning. What is sigma fx algebraic sum means in x direction and y direction? How to calculate these forces, horizontal, vertical and moment? Horizontal and vertical, there is no inclination. Algebraic sum of all inclined forces equal to 0. It is not there as an equilibrium condition. So what to do when it acts for equilibrium, when inclined force is acting on them? We have to resolve this inclined force system into two components, horizontal and vertical component. It is made with some angle, that is some unknown angle we consider as theta x. We have to resolve this P3 into horizontal and vertical. That is P3 cos theta 3 and P3 sin theta 3. Similarly, P2 should be, and also P1 is already acting vertically downwards. So when there is inclination is there in action of the force that should be resolved into horizontal and vertical, then we have to consider all or sum of horizontal forces. Suppose P2 is acting in this direction, P3 cos theta 3 is acting in positive x. This P2 horizontal component is acting in negative x direction. Now the positive x direction is considered positive, negative x direction is considered negative, then P3 cos theta 3 minus P2. Like that we have to consider it. That's why it is called algebraic sum. Both the positive and negative terms will be there in that. Now here, like that sigma fy, the positive y direction and positive and negative y directions considered as a sum. That sum is known as algebraic sum. And moment equilibrium, what is this moment? Taking the force into perpendicular distance is known as the moment equilibrium. We have to consider it about certain point. So these are the glimpse of first module. One has to focus it. And one more thing, the types of problems we can occur, that is for there are 2-cylinder problems or 3-cylinder problems. Okay, 3 cylinders problems which are coming. These are contacting points. Okay, if you want to find out the reactions at those contact surfaces, we have to use equilibrium conditions. Here this contacting, and we know the weights. So by using, this is one of the problem, and another problem is that okay, this is another problem. So if you want to find out the point of contacts, at this point of contacts, the reactions, okay, these are the reaction forces, we have to use equilibrium conditions. Thus we can calculate the reactions. So these are the types of problems one has to use, one can solve by using equilibrium conditions. Now coming to the next module, that is module M2, that is known as friction. In the case of friction, only one thing is that equilibrium conditions, that is along the plane AP, or sigma AP equal to 0 and normal to the plane sigma NP equal to 0. We have to resolve it. These are the equilibrium conditions we have to use. What is the friction? Law of friction is that F equal to mu times R and mu equal to F by R. This F equal to mu R, but here the surfaces are rough surfaces. So the problems comes under in this category of the friction. There will be some inclined plane. On this inclined plane there is a surface on rough surface, and you have to find out the angle of we have to find out the coefficient of friction or anything, the frictional force or angle of inclination are to be calculated with the help of these equilibrium conditions and law of friction. And the third category here, one more thing, there are under the applications of the friction, one is, there are 3 types of applications. One is ladder friction, another one is wedge friction, and the third one is, what is that, screw jack. Okay. Now under these considerations, what to do? We have to find out, we have to apply these equilibrium conditions, and we have to use the law of friction and find out the reaction forces or frictional forces. What is the wedge ladder friction? When the ladder is lying, it is sliding here. What is the coefficient of friction at this point, contact points? What is the wedge friction? The wedge friction is that, what is the wedge friction? Wedge friction means here when there is a body, wedge friction here, this is known as, this is the wedge and it is the body. The body is waiting, acting vertically downwards, and wedge, if you push the wedge in the direction, the body moves upwards. In order to lift the heavy weights, we used to use wedge. And what is the friction between these contact surfaces? These are the contact surfaces. Okay, these are the contact surfaces here and here. We have to first how to do body consider, draw a free body diagram. Okay, and here this wedge you consider and draw a free body diagram, apply equilibrium conditions, and you will get the required objectives. Okay, and the next, the third module is module 3. What is the module 3? Center of mass, center of gravity, and moment of inertia. This center of mass or center of gravity, here center of gravity, the location of the center of gravity can be done by bar x equal to a1 x1 plus a2 x2 plus and so on, an xn by a1 plus a2 plus a3 and so on an. And bar y is considered a1 y1 plus a2 y2 plus a3 y3 and so on by plus a1 an yn by a1 plus a2 plus a3 and so on an. Now the point is that this bar x and bar y represents the coordinates or location of the centroid of the system of the planes. That's why it is a centroid. Okay. Suppose if you are considering any I section or T section, it is symmetrical about both x-axis and y-axis. The half of the distances of the total section is the location of the centroid of the system. If it is any arbitrary section, how to locate the centroid? By using this mathematical derived expression, that is bar x and bar y, we can locate the centroid of those geometries. So here we are going to consider the planes, two-dimensional objects. That's why bar x, bar y used. If they are considering the three-dimensional object, that is the solid volume, then we will use the term that is center of gravity. Okay, now the point is the centroid helps to calculate the moment of inertia. And also centroid helps the location of the complete concentrated load, complete concentrated weight of a particular body, such a way that the body balancing of the system can be taken place. Now coming to moment of inertia, there are two types of moment of inertias in the case of module 3. One is area moment of inertia and another one is mass moment of inertia. This area moment of inertia is used for two-dimensional objects, whereas for mass moment of inertia is applicable for three-dimensional. Now, what is the area moment of inertia? This area moment of inertia can be calculated by using two theorems. One is a parallel axis theorem, and the another one is a perpendicular axis theorem. In the case of parallel axis theorem, what is the parallel axis theorem? About Ixx equal to Igx plus a times bar y whole square. What about perpendicular axis theorem? Izz equal to Ixx plus Iyy. Ixx I mentioned here. What about Iyy? Iyy equal to Igy plus a times bar x whole square. These are the parallel, this Ixx, Iyy comes from parallel axis theorem. The sum of both the things is known as perpendicular axis theorem, which is perpendicular to the plane. Okay. Now, the unit for area moment of inertia, that is mm power 4. Okay, similarly, unit for area moment of inertia in the case of perpendicular axis theorem, it is also mm power 4. Now, these are the glimpse of the module 3. Coming to module 4. In the case of module 4, we consider the kinetics of rigid body. The kinetics of rigid body consists of, it is the study of both force and the motion. Motion such as the velocity, displacement, acceleration of the body, and also causing those motions, that is a force. The factors we will consider F, that is F, velocity, displacement and acceleration. This is known as the kinetics. What is the F equal to mass times acceleration? This VSA related to kinematics part. That is also, those are the equations of motion are to be considered in studying the kinetics of rigid bodies, such as V equal to U plus AT, V square minus U square equal to 2AS, and one more thing is that S equal to UT plus of AT square. These are the equations. 4 equations are considered to study the kinetics of rigid bodies. So in the case of kinetics of rigid bodies, the main thing is that we use the principle of D'Alembert's. What is the D'Alembert's principle? D'Alembert's principle says that the net force and the inertia force both are said to be in equilibrium. That is F minus ma equal to 0. What is that F minus ma equal to? This is the net force. This minus ma is known as the D'Alembert's force or inertia force. The sum of net force and inertia force is equal to 0. Algebraic, the sum completely. Now, both should be in equilibrium. That means F equal to ma. This F equal to this ma is known as inertia force. This F is known as the net force. So, what are the cases we are going to study? As in the case of kinetics of rigid bodies, there are various cases are there. One of the cases is that plane, and what is the force of an inclined plane? What is the acceleration of this mass? On a smooth plane. On a smooth plane, we'll study the acceleration of this mass. That is known as by using the kinetics of rigid bodies concept. We can calculate. The second case is that if the surface inclined plane is rough surface, rough inclined surface, what is the acceleration of this mass? That is the second case. The third case is that if the two bodies are hanging around W1 and W2, what is the acceleration of these masses? And if one mass is on stable condition, another mass is affecting the weight. This is W0 and W1. What is the acceleration of this mass? That weight. With the help of using the concepts of kinetics of rigid body, we will calculate here completely the accelerations. One more important, by using kinetics of rigid bodies, another case is that analysis of the lift. If the lift is moving upwards, what is the tension in the cable T? If the lift is moving downwards, what is the tension in the cable T? So this analysis of lift also can be done by using the concepts of kinetics of rigid bodies. Now finally, coming to the vibrations, impulse, momentum and vibration, M5. In the case of M5, we have to focus mainly for examination. Keynote is what is momentum and what is impulse, what is the coefficient of constitution or coefficient of restitution, coefficient of restitution. These are the three concepts one has to focus, and important is that coming to vibration topic, in the case of vibrations, solving what is simple harmonic motion. In simple harmonic motion, what is velocity, what is acceleration, derived expressions, and also problems on this velocity and acceleration components. So coming to simple harmonic motion problems, when the particle, especially this case study is very important. When the particle is moving in circular direction along the circumference of the circle with uniform angular velocity, making an angular displacement theta, then the motion of the particle n, that is the distance at a distance of y from O, and is along the y dash axis. Okay, the motion of this particle n is known as, and y dash is a simple harmonic motion. Now whatever this r is the amplitude. So what is the y equal to OP times sine theta. What is the OP? OP equal to y, OP equal to r times sine theta, theta equal to omega t. This is the displacement equation. If you differentiate with respect to time, if we differentiate the displacement equation with respect to time, obtain the velocity, that is y dot. If you differentiate the velocity equation with respect to time, that is y double dot. That is known as acceleration. That is minus omega square times y will come out. The acceleration is always. So by using these equations, we have to solve the problems. So with this, we completed here the glimpse of our view of complete 5 modules in this session. Okay, with this we can wind up the session. Thank you.
Like, share and subscribe. hit the bell icon for more updates.